Alright, I think I'm live. Of course, I have no idea. I should test this before I send stuff out. Tellarian.js people. That is me. I'm... Channels? I should be active. Ah. Advertising.
Surprise, bitch! You're dead! Oh my god! Oh shit, you're on fire now. Yeah, no, run away. That's all you can do. And in his first place, no, no, no. No, you're fucking dead. No, 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 you're cheating. That's fucking
Yes, continue blocking. Channel. Good, nobody here yet. Edit. Playing. Broadcast language, be English. Okay. I think we're set. I think we're set. Now I hope to God that this doesn't freaking freak out on me. Right, I need to... How do I do this? Doing things. Thank God I have a computer and an iPad. Seems to be working. You should see the back of the iPad. Blah. Ba-da-ba-ba. Who is sending me messages? Why is Sam sending me? Alright, let's see. Yay, I have a viewer. It's probably me. Ta-da, it's me. Let's see if this works. Where did... Control C. Control V. Post. Alright. Doohickeys are sent out. We have doohickeys. I think I'm good. Alrighty. Let's see, bitrate dropped. Total bytes. Alright, I think we're in business. Okay. Totally in business here. Alright, so I guess I don't really have anybody in the room right now, or if I do, my doohickeys not updating. But that's fine. Alright. So today I need to figure out, we're going to be making a new camera feature. Right now, the way the game works is the camera will follow the party, but when you start running in a specific direction, you get really far behind. The camera lags, and it's kind of annoying because when you're running in a direction, you'd like to see where you're going as opposed to just running blindly, I guess. Running blindly is not that great. So yeah, you can see the camera lags, it falls behind, and it should be... Yeah, we have an invisible gamepad here. Ideally, the party should be centered on the screen at least, if not the camera moving a little bit further ahead. So I'm going to try to do something a little basic here. I probably won't get everything right the first time. We're kind of doing it live. So let's crack on with it, I suppose. Alright, so there's two things I need to do here. One being calculate the central party point and do a bunch of calculations to offset the camera, and then there's the actual case of offsetting the camera. So, believe it or not, offsetting the camera is the easy part. So, I have our exploration camera code up. It's all very exciting, whatnot. And this is the exploration camera. And there should be a method in here. Should be update camera position. Surprise! The, good method names and all that jazz. So, we have a camera to look at, we have things to consider, including the camera view. And we have starting camera distance, camera starting position. So we basically have, alright, where are we starting? And then we calculate the target look at, which isn't quite the same as what we want. So the camera is pointing at a specific spot. So if we look at the exploration camera in Unity, and there's a camera look at object. So if I go to the scene here and so we go to the scene here and we look at the camera, and I'm actually going to run the game. Waiting for the game to load. So, alright, so if we look at the scene itself, we can see that the camera look at is that sphere there. And if I look at the whole, level container, content, exploration camera. So if we look at the whole camera, we see that we have the frustum, and it's looking at it, and then as the character moves, which I'm gonna pull this out here, as the character moves, so you can see the look at is lagging. You can see that in there, and that is the problem. So we need to basically have the look at get pushed forward. So, boop. So that's getting calculated here as where. So it's using the target look at for players. It's also using a bunch of other stuff. A bunch of other stuff to figure out what it needs to do. And then this is the actual update here where it actually calculates where it's moving. So we calculate the target look at, we pass in, we have update camera cage position. It does a whole whack of stuff, which is going to be the really hard part, is figuring where that out. So for now, I'm going to cheat and I'm going to add a public vector. And I'm going to call it cheat camera adjust. And that's going to be a new vector 3. So it's going to start at 0, 0, 0. And that way, while the game is running, I can basically futz with it. So the exploration camera, target pan amount, calculate how much to pull the camera out, apply the target push-pull vector. So the position is the smooth pan amount, which is a small amount, a slice of how much we want to get it. And so what we're going to do is at the very end, well, hold on. So if any, pardon me. Let's see, keeping the push pull, so record the new distance, set target cage, So there's the smooth pan amount. And then there's also the stuff that we need to move. So we're going to be changing the smooth pan amount, because we're going to be modifying the target look at. So the calculate target pan, target look at. So I would like to, so if we adjust the target look at, everything else should just follow. Because it should do a bunch of calculations for us. So here, calculate target look at, go into here. So this is in another file. Aha, right, okay. So this is the target look at in terms of where it wants to go. Because it's the player centroid and the enemy centroid and the object centroid. Versus here, calculate target pan. Right, so we calculate the target look at, and then we have the current look at. So, yeah. All right, so we're going to be adjusting the target look at. Be adjusting the target look at, which is exciting. So we're using markers as true. That's the default. Yeah, so in this case, we're going to be calculating the centroid of the players and adjusting it from there. So let's see. I know this isn't really exciting. This is the whole not very glamorous part of game dev. Because we're doing it live. So, alright, so calculate, target, look at. Things to consider. We have the current camera look at, the position. Why am I sending that? Ah, that's the default look at. That is what we use if we have nobody on screen. Alright. Alright, so things to consider. Why do we calculate target look at twice? Oh, because this is with players. Ah, right. Okay, good. Yep. So we have the target look at with players here. So we can ask, we can see if we can request it. So we're already calculating it. I don't need to do anything else. So thinking. Calculate everything based on the players, not the markers. So we're recalculating it every frame, which means that I should be able to say, all right, target look at markers plus equals, and we're gonna add our configuration cheat camera. I'm gonna call it a offset, cheat camera offset. Cheat camera offset equals configuration dot cheat camera offset. That compiles. Go to here. Let it compile in Unity. We watch Unity break. Oh, Unity. Exciting! Alright, we're back in. And that should have worked. So I should be able to go to exploration camera. Cheat camera offset. Here we go. So I have cheat camera offset. So for now, if I don't do anything, I'll just leave it. The camera should work as normal. Half the difficulty in this is trying to find the right spot to put the code. Alright. Camera is still working the way it did before, clearly. Nothing terribly weird. And then we set Z to 5, X to 5, and voila, we have our offset. But if we set it back to 0, it should go back to normal. And you can see that all of our code already handles the smooth pan effect. So we don't need to do anything more except tell it, hey, I need to offset this by this amount. So brilliant. That's done, dusted, we're ready to go. And that's not a big deal. I mean, I could offset it by Y, which is weird. but I could. But really, for the most part, we're going to be offsetting it by the XZ plane. Because XZ plane... Alright, so that works. Brilliant. So that was the easy part. I figured out where I need to add the offset. The next part is calculating what the offset should be, and doing so in a way that makes sense in the game. So the easiest dumb way, we're going to do the dumbest way and see if it's sufficient, is basically calculate what the current party velocity is, and then use that as a scalar. Use the velocity and the normalized vector and some other magic thing a magic number somewhere I gotta figure out, and use that as the calculating the offset. We'll probably want to do something in terms of, so we'll need to add a dead zone eventually, because you don't want the camera to be jittering all the time. It shouldn't like immediate, and you hear all the fire station fire alarms, hooray. But we don't want the camera to jitter, like having it interact the second that you start moving or start running is going to make the camera really jerky, and we don't want that. So not only are we going to have to figure out what's the vector, so what is the party, the composite party velocity, what is their composite party direction, and also, like, how many frames do we wait to see before we start moving it. So for those of you who just joined us, you can see that the first thing I did was we have an offset. What we're trying to figure out is, like, right now you can see the camera is following rather than leading. So we want the camera to be, we basically want Barrison here, good old Barry, to be at least at the center. So when it starts moving, the camera should really have caught up already, and ideally have extra space in front so that they're watching. And so the first thing we did was figure out, all right, where in the code do we need to add this magic offset? And now the next thing we're going to do is the more interesting thing, which is calculate what that offset should be. So in the code here, this is the cheat camera offset, and now I gotta figure out, all right, so we know that here in this calculate target look at, we already calculate the centroid with the players. So that basically calculates the position. To figure out what the party velocity is, we basically need to frame measure the current party position. So frame 2, if the position is here, and frame 3, the position is here, then this vector is the distance. This vector is the direction and distance that they're moving. And so over time, we can basically calculate a velocity. So what I'm going to need to do is I'm going to need something that tracks their position from the current frame and the previous frame, and we need to calculate what their current velocity is, and honestly we'll probably want to do some sort of average over time, but we'll do the super simple thing first, which is just a frame to frame velocity, and go from there. So I know that I'm going to get this centroid here, which is what I want. And I'm already calculating it, so calculating it twice would be dumb. And we always calculate it every frame. So, I'm going to do vector 3, and it's going to be party centroid equals, what's a good default for this? I guess the current camera look at would be the best default. Current camera look at, transform, because at the very worst, if that's the default, then it shouldn't jitter too much, I guess. I don't know. It's a default. And then we're going to want to get it out of here. So this is the target look at players, but we only want part of the target look at. So use markers, vector. This is kind of cheating, but whatever. It's not really. So out vector 3, player centroid equals null. Actually, you can't null it because that's a struct, right? Out. Yeah, I cannot have. Optional parameters must. Balls. Alright. I am going to make a new method. Public static vector 3. And it's going to be the same method, but I'm going to overload it because I don't really want to calculate target look at. We're just going to do this. Ba-ba-da-boom. That's going to be the quote unquote old one. And this is going to be the new one, which has the use markers. And it's just going to be a stupid vector 3 dummy vector equals dummy vector. Actually, you know what? No, this is not very bright. Hold on. Thinking. Hold on. Use markers. Out. Vector 3. Oh, it can't have a default parameter of null, but it can be null. So I'm going to do this. Null. That out vector 3. Player centroid. And no, I can't call it player centroid because party centroid I get to call it because it's the party centroid. Party centroid. It's a party in the centroid. So party and centroid. If centroid does not equal null, then we're going to set it. Oh, that should be a ref. That's why. That shouldn't be. That should work, right? Target, best overloaded. Ref null? If this was C++, this would be easier. I just want to send it null. I don't want to do this. This would probably be easier if I wasn't on camera. Alright. This is balls. Let's kill that. So I want calculate centroid. Party centroid. No, that's going to be an extra calculation. I don't want to be doing that every frame. Alright, so this isn't going to work very easily, so I'm going to try a different tack entirely. So we're just going to do everything here. Goodbye. Alright, back to our original thing. That wasn't going to work very well. So, screw it. We're going to recalculate it for now. I will worry about fixing it later. So public static vector 3 calculate party centroid. Things to consider. And that's going to be a return. Alright, so that's going to be calculate party centroid, and for funsies, I'm just going to do this, because it's the same deal. So, alright. Let's see, what do we got here? Alright, so this is the party centroid, so this is going to be the middle point, and we can get it, that's not a problem. We're calculating it, we're going to calculate it twice, which is not pretty, but I will worry about that later in here. So here I'm going to make a target look at markers plus equals calculate party velocity camera offset, and I'm going to send it. We don't need the current camera look at, but we are going to need the what is this, exploration camera math utilities. So we are going to need it, the calculate party centroid, and I need to send it things to consider, and I can get rid of this. That's right, and then so now we have our new calculate party centroid camera offset, which we have the centroid. So I'm not going to do it in exploration camera math utilities because I need to make sure that I store state between frames, so it doesn't make sense to put it in the static helper class. So instead it's going to be here. It's not great, but whatever. And I'm going to return vector 3.0. Actually, no, I'm going to turn vector the party centroid. And I'm just going to return party centroid as the default, because that means that... No, that's not right. The default should be vector 3.0, because there should be no offset by default. Alright, so at worst, right now, this should not affect the game whatsoever. I'm going to try to compile it, because I haven't compiled for a while, and that's always a good thing to make sure you compile. And we're going to play with it like just something stupid and make sure we haven't affected anything. I'm pretty sure I haven't, but can never be too careful. Oh, hooray! Unity didn't crash this time when I compiled. That's great. Good job, Unity. Boop, 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 boop. Waiting for it to load. Alright, let's see. Barrison goes left. Barrison goes right. Everything looks to be good, and the cheat camera offset doesn't do anything anymore because I just disabled it. That's great. Okay. So now we actually have to do the calculations. So, as I said before, I need to store the location from frame to frame and use that to calculate their current velocity. Yes. Yeah, because the velocity... Yeah, I'm not calculating their acceleration. That would require more than one frame, but calculating their velocity only requires one frame. So, private vector 3, previous frame party position. Assume the party position. Equals equals vector 3.0. We'll just do that because it's all right, so the first thing we're gonna do is, or the last thing we're gonna do is we're always gonna set the previous party position, frame party position to the centroid, because we have to update it every frame, otherwise none of this works. So now, previous frame party position equals centroid. And if everything else is going to be if I need a special case for, I can either make it a bool or I can special case it. But if previous frame party position, actually, you know what? I'm going to make a bool because I don't really want it that way. So private bool, party position ever set equals false, because we'll get divide by zero errors or whatever on the very first. We'll get weird behavior if I try to set the offset on the very first frame of the camera's existence. So it's probably overkill, but I want to make sure that this is correct at least, and we can do that. So if we've ever run this, true, done, that's it. We can just set it to true. I don't need to worry about reading it, because I can read it if... Actually, do I care? Because the first frame is going to be behind a loading screen. You know what? Screw it. I'm going to pretend that... No. That's not right. Or it will be right, but yeah, no. I need to worry about the first one. So, if party position ever set equals... Alright, so everything, our actual calculations are going to occur if the party position was ever set. Because if it's not set, then we are storing the very first frame, special case, very first frame, and we don't want to calculate any secondary stuff. I'm wondering... This is going to be problematic for TPK teleport too. Actually, teleporting the party at all is going to be problematic. I will put a to-do special case party teleport to reset velocity calc. Because if the party teleports, we are going to have a frame where their velocity is stupid high, like to the point where we should be ignoring it. Yes, that's right. Okay. So that's what to do. We'll figure that out later. So if the party position is ever set, then... we need to take the previous frame and the current frame, subtract. Okay, so vector 3, party, not party. It's not really the direction. It's the direction, and it's party displacement. So it's the party displacement vector. It's the full vector, and it's going to be. God, I can never remember this. This is it's either a minus b or b minus a vector subtraction. I can never remember. Let's see, u v v1 minus v2 is the, all right, good. It's v1 minus v2. I don't remember. I hate this. Well, hold on. It's the first direction, the first position to the vector, the second position, and we're doing this. So it should be, yeah, 1 minus 2. Yeah. So if we're doing it, oh no, that's from B to A. I want from A to B. My brain. So from B to A to B. So it should be B minus A. All right. So it should be the current position, which is the party centroid, minus the previous frame party position. Yeah. So that should be the party displacement. And from there, we can calculate, once we have the party displacement, from there we can calculate the current velocity, and the normalized vector should be the direction. So float velocity for this frame is party displacement. No. Auto complete, you fail me. Party displacement dot, I want the magnitude, but I actually want the square magnitude because I don't really need to do the regular magnitude because that requires the square root. That's slow. I don't really actually care that, so it is the square root velocity. And then we need vector 3 direction equals, the direction is going to be party displacement normalized. Done and done. Okay, so now I have the current velocity and the current direction. So using those two things, I need to figure out, all right, how are we going to displace the camera using this information? Direction is clearly going to be the direction that's displaced. And velocity is going to tell us how much we should be displacing it. But we need to have sort of a baseline value that we're using. So the question is, what's going to be the baseline? I'm going to make the baseline just a 5x5 vector on a 5x 5z vector on the xz plane and call it a day. Actually, that reminds me, party centroid, I actually want to drop the y component because I don't care. We're only doing this calculation on the xz plane. So I'm going to do vector 3. Actually, if I'm taking no, I'm going to copy it. I don't really want to. Party centroid xz, xz equals new vector 3, and it's going to be party centroid.x, 0f, and party centroid.z. And that will basically flatten our vector to the xz plane, which is the only piece that we care about. Then if the party position is ever set, right. Yeah, because we don't have elevators, and elevators would cause so many problems in our game. I know design wants elevators, and I'm like, you can't have elevators. Can't. Or at least it'll be very difficult to implement elevators. Because of all this, very, very many times we ignore the Y component, and just going straight vertical would suck. So party displacement, centroid, minus the previous frame position, is square velocity. We have the direction. So yeah. Okay, so now we want to figure out how much, okay, so this is going to be private const vector 3 stupid test vector equals new vector. Oh god, I'm not that clever, Ed. New vector 3 5f 0f 5f and this is my stupid test vector that we're going to be doing this stuff on. So stupid test vector, which later we'll calculate as an actual thing, probably based on how close the camera is to the hoo-ha. That was not what I meant. How closely the camera is to the party. So square velocity, which if the velocity is 3 is going to be 9. Actually, maybe I do want the regular velocity because the square velocity is going to be a pain in the butt. Maybe I do just want the regular velocity. It's not as cheap. Magnitude. Alright, so I have to figure out what the maximum possible player velocity is, which I think, if I recall correctly, it's 8 right now. It's a magic number. Yeah, so the camera pan speed is 8, and then, did it? Vector 3 cannot be const. Well, la-di-da. Fine. But if I go look at the actor, prefab, actor, sure, no, I want to look at players. Players, resources, battle mage. Battle mage. Alright, so if we go to her, not her movement AI, but we want her actor nav mesh agent, her acceleration is 8, her max speed is 3. So 3's not that much. Alright, well, we'll use that as the magic number. So that's going to be the, and I can't make this const, so fine. Private const max player speed and private const float max player speed. So that is going to be how we scale our vector. So if we're at maximum velocity, we should use 100% of our stupid test vector. If we're at half velocity for whatever reason, i.e. maybe only half the party is moving in that direction, we should use half the direction, the stupid test vector. So I'm an idiot. I don't need the stupid test vector. It should be displacement. It should be a displacement, not vector, scalar equals 5f, because we should just multiply the normalized direction by the scalar. So we're going to basically take the, it's going to be velocity divided by max player speed, so that it should range from 0 to 1. Max player speed can't be 0, so there's no possible way we can get it divided by 0. So velocity divided by max player speed times the displacement scalar, and that is going to be multiplied by the direction. So this is going to be vector 3, vector 3. Vector 3, our displacement, our camera offset. This should be the camera offset. Camera offset equals, so it should be velocity divided by max player speed. I need a semicolon here. Velocity divided by max player speed times the displacement scalar. Why are you... But, oh, ha! Boom! There we go. Times direction. Direction is a vector. These three are just numbers. As long as the scalar's on left to right, we're fine. That is the camera offset. I'm actually going to make this camera offset at the top. I'm going to default it to vector 0. And I'm going to have this method return the camera offset. And we're not declaring it in here anymore. So, to cover what I've done so far is we have this calculate party velocity camera offset. We're tracking the party position, the party centroid, like so all the players, and we're tracking it every frame. If this is for the first frame, it's kind of dumb, but there's no way around it. So the previous frame party position, we're setting it we're setting the new one every one, and then so we're taking the velocity and we are just saying, yep, all right, this is good. Displace it by 5, which I have to figure out how to calculate this. This is a to-do. Shouldn't be special number, should be calculated. This is a special number based on max player speed in the nav agent, which I don't have a special const anywhere for. This has nothing to do with that. So calculate party velocity camera offset. Party displacement, velocity, direction, and the actual offset. And that should work, I think. I feel like this should be in a separate class or something. I will figure that out later. Alright. So let's see what happens when I test this. Godspeed. It should be great. It's compiling. Compiling. Also, I'm really excited that my computer hasn't blue screened yet, which means it's really just the iOS streaming crap that causes a blue screen, which is really sad. So sad. I have no idea if people are in the chat room or anything, because I see people watching the stream, and I think I'm getting it, but I don't have Who's of Which Madui Flash running, so I don't know if it's just echoing like crap and pretend it's working. Alright, anyways, let's give this a whirl. Hopefully it doesn't explode. Drum roll. Level is loading. Has not exploded. I don't see a bajillion errors in the console log. It also doesn't seem to be doing very much. I mean, there's an easy way to test this. Let's attach. And oh, huh. Party centroid, we're actually getting a value. Party position is ever set. So previous frame, which is 0, which means our velocity is 0, and our direction is 0, which means that the camera offset is 0. Alright, well, the basics work. Ooh, actually, what I should do here is condition velocity is greater than 0. Okay. And velocity is greater than 0. This is good. It's good. Alright, let me make this so that the velocity is actually like 3 or something. It's never 2. The velocity never reaches 2. Which is interesting. So maybe my 3 is too high. What if the velocity is greater than 1.5? Do we get up to 1.5? No, we don't. Man, our characters move so slow. Sort of binary search. Man, we don't even get up to 1.25? What? I saw it get up to 1, so I know that much. So screw it, we're just going to say if it's greater than 1. Am I even attached? No, I'm attached. What is going on? My velocity is definitely greater than 1. Velocity is greater than 1f. Or maybe the debugger's being stupid. Velocity greater than 0. Did I say 0f or did I say 0 before? Maybe I should just use greater than 1. Maybe it's the f that's throwing it off. No, it's seriously dumb. I don't understand. Don't tell me this is something that has to do with C# being stupid. No, it was working before, and now it totally isn't. Condition velocity is greater than 0, f. Blah! Okay, it's up to 1.1. Okay, good. So the camera can move with that, and then I let go. Party direction. Okay. 0.25, 1.59, 1.66. Okay, so we get up to 1.66. This is our maximum velocity. Okay, so that means the max player speed should be much slower, much lower, which is a magic number, and I should figure out a way to calculate it. But you know, screw it. That's way too much work. So for now, we're just gonna say 1.66, and then we'll see if this works better. Party centroid is assigned but values never used. What? Oh, wow, I'm an idiot. Although I wouldn't have noticed that on this one. Previous frame position should be party centroid xz. Unity, no! Unity, why did you do that to me? Unity is crashing. Unity is always crashing. Whoops, I did not mean to open Mumble. No, stop Mumble, what are you doing? Unity is compiling. So, how is everybody? Party Centroid is assigned but never used. Oh, yeah. Don't need that. Alright, let's try this again. What? Why am I offline? Weird. Alright, so let's test this again. Alright, let's see. It's definitely working, I think. I have no idea. I should do is I should make a, instead of a cheat camera, I'm going to call it a float. Let's see. Cheat. It's definitely working. Scalar. 5F. I have no idea. I should do is I should make a, instead of a cheat camera, I'm going to call it float. Cheat. Alright, so it's going to be, instead of displacement scalar, I'm going to do config dot cheat scalar. Then I can just crank that. Crank it. Compile, 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 compile. Ba-da-ba-da-ba-da, ba-ba-ba. Right, compiled. Let's run it. This has got to be the most boring stream ever. Seeing the sausage being made is just really not exciting. Alright, so let's go to the camera, no, level container, content, camera, exploration camera. Alright, cheat scalar. Let's crank this up to 50. Let's just do something completely stupid. Wow. I cranked it to 50 and it clearly works. Let's crank it up to 100. A 1,000? think at this point I'm stuck with the pan damping. What if I reduce the pan damping? Ooh, that worked. Pan speed. Ooh. Oh god, this... Ugh. Okay, let's bring this back down to like 10. Ten is not very much, and it's not really enough. Ugh, it's kind of making me sick. Oof. Alright, so we clearly need some sort of averaging for the actual direction, because that's... Or I can increase the... Hold on. Put this back and just have the... Oh god. What is going on? That is terrible. Oh boy. Alright, let's play with that a bit, and it's almost there. So let's see, so we got velocity. I'm going to do this so I can read it as vector 3 camera offset. Just so that I can read this stuff as we're playing. Exciting! At least we have something that mostly sort of almost works, except it gives me motion sickness, which clearly bad. It's kind of an advantage to being really easily, like, motion sickness did, I guess. Is that I can look at a camera and go, no, this camera's crappy because I'm going to vomit. Vomit cam is not something we want. No vomit cam. That would be terrible. Alright, let's see. Camera offset, which is super tiny, because their velocity is super tiny. Wow, that's not a very high velocity. Oh, because I'm an idiot. I am an idiot. I shouldn't be doing it per frame. I should be doing it over time. I can't be using frames as herp derp. I should be doing it over delta time. Velocity equals magnitude divided by delta time. Delta time? Yeah, that's right. Because I'm a moron. Moron. Clearly not as clever as I had hoped. Alright, let's test it again. This should make that much more consistent. Yay, look at that! My velocity is now 5. Ta-da! That's exciting. Let's up that pan speed. That's looking much better. Ugh. Spinning still sucks. Alright, so. What the? Why is it doing that again? What is up with that jitter? What is the deal with that crazy ass jitter? Why is it jittering? What the F? Alright, so we have something super basic that works. I have to do some work with the pan speed needs to be increased. What is the pan speed on our base? Prefabs. World objects. Is it on world objects? Where's UI? Where's our camera? Tools, resources. Where is our cameras? Exploration camera. Pan speed is 8. Might have to boost that up. But this can go away. This can go. Vector 3. Velocity, camera offset. And, why are you, oh, because that shouldn't be a vector, that should be a float. So, the displacement scalar should be calced, because depending on how close it is and versus how far it is. Also, max player speed is not this. Max player speed should be 5. Wait for it to finish compiling. Ba-da-ba-bum. And, right, I need to up the pan speed, because otherwise it doesn't go fast enough. I think my scalar needs to be bigger. I think my scalar needs to be bigger. What the what? What did I break? Man, WTF, what did I do? Why did it break? It was working before. What did I screw up? Cheat scalar. Priority displacement magnitude over delta time. Priority displacement normalized. Velocity. Camera offset. Camera offset. This should work. What did I screw up? What did I screw up? I changed this. Let's put that back there. That shouldn't have affected it that badly, but it may have? Why doesn't my code work? Why doesn't my code work? Max. Oh, character camera margin. That's what it's like. Oh, what is that value? Alright, let's try again. Also, my cheat scalar is really big suddenly. Went a little bit ahead, but not a lot ahead. What have I done? Why is this broken? Why is the previous frame party position not updating? What did I do? Previous frame party position. Previous frame party position. Why is that not updating? That should be updating. I'm an idiot, that's why. Oh my god, I need to fix this. It wasn't updating because I was changing the freaking prefab, not the actual thing with the stuff and the. Oh my god. I feel like an idiot. Okay, those are the old prefab sets. Exploration camera. This is the one that I need. Alright. So pan speed is going to be 16. Cheat scaler is going to be 10,000. Ten thousand is going to be overkill. I was changing the pan speed, but it wasn't getting picked up because this is thinks it's set here. Woo! There we go. All right, we're back. We're back in business. Oh god. What if I set the pan speed to 12? That's a little better. It needs to be higher than 8. Yeah, because if I do the max pan speed, I don't think the cheat scaler needs to be that high. Yeah, no, 10, even 10 is sufficient. Well, we'll have to calculate it based on... Basically, what I want to do is I need to have... We basically need to calculate the look at to be a very specific spot ahead. So if the size of the screen is this much, this much, this much, then the look at should be like on the other side, I think, or something like that. And then so if the size of the screen is this much in game space, this much, here we go, this much in game space, the scaler is going to have to be bigger. So the scaler needs to scale based on how far back the camera is, because screen. But it's working way better than it was before. At least with one character. I'll have to try with 2. How is it on the profile? Oh, it's not bad at all. It's still only 1%. Haven't really futzed with it. Alright. So, yeah. I think I'll leave it at that for now. That's the basics. I've implemented the very most basic version of the feature. That took me an hour and a half. There's still lots of little things to sand down on it. Like I need to do the correct calculations for pullback and whatnot. I still need to figure out special case for party teleport. I still need to do probably do some smoothing for the swing. It was really swingy. We still need a dead zone. So I have the basic prototype. There's probably another 8 hours of like futzing and fiddling of work, but that is a actual camera that doesn't lag behind the party, but goes ahead of the party when it runs. Yay! It's not stupid anymore. I say that as the person who wrote the whole camera system. That, I mean, and it's really not stupid to begin with. It's just was missing this bit of functionality. Yay! It's not stupid anymore. Look, it you can see ahead instead of... Where's the thing? Alright, I'll do that. Yay! Alright, so, like I said, lots of sanding to do still, but that's not going to happen on camera because that's going to be like a day's worth of work and way too much. So, those of you who joined me, thanks for watching the last bit. But I'm out. Have a good night.